here. Let's turn my computer here so we can see, and maybe it'll pick up my voice. I don't know. So part of the thing that you want to know when you're doing a problem like this that you really kind of need to remember is that I'm going to try and say this correctly. Log 7 minus log 6 is log 7 over 6. This is the division property, right? This is not the division property. So don't get confused here. Yeah?
Would log 7 minus log 6 equal log 1?
No, absolutely not. Don't do that. It is not, this is not equal to log 7 minus 6. This is equal to log 7 divided by 6.
Okay.
Okay? And 7 divided by 6 is not 1. So don't, the logarithm is not a distributive, not something you distribute.
Please receive instructions to Mari McCarthy. Please come to the front office. Mari McCarthy, please come to the front office.
So keeping that in mind, this 7x minus 8 and this x plus 1 and this x minus 1, those are arguments of separate logarithmic expressions. And I know when I'm kind of arranging these, when I'm condensing them, that if they're positive, if the logarithmic expression overall is positive, it goes on the top. And if it's negative, it goes on the bottom. So I want to combine these here. I'm going to forget about that 1 for a minute. I'm just going to leave that 1 alone. So I want to combine these here. It means I can have log base 2 of, well, 7x minus 8, that's a part of a positive logarithmic expression. So that's going on the top. 7x minus 8, that's going on the top. And this x plus 1 is part of a negative logarithmic expression. So the x plus 1 is going on the bottom. And this x minus 1 is also part of a logarithmic expression. That's also going on the bottom.
You can do more than one binomial at once.
These aren't.
They all have the same base?
Because they all have the same base.
Oh my god.
Because they're all log 2.
Are
Right?
we going to have to deal with anything of different bases on our exam?
Be prepared for it.
Okay, because I had a question on one of those. So.
We'll get to it. Yeah.
So for example, if log 2 7x minus 8 was also negative, it would be 1 over that whole thing?
That is correct.
Okay.
That's right. So if I had, negative log 2x minus log 2, same base, y, that's going to be 1 over x y. Okay? Now, let's just look at that just a little bit differently, okay? How do I get to that spot? Just so you can kind of maybe take a different route and understand why it's like that. I'm going to take my original expression here, and I'm going to change it. I'm going to change it to negative 1 times log 2x plus log 2y. Everybody okay with that?
Okay, how did you get from log 2 7x minus 8 over x?
No. We're taking a detour here.
Oh.
We're taking a detour here for a minute. All right, because Candace asked the question, if I have negatives in front of all of my logarithms, does that mean they're all on the bottom and 1 is on the top?
Oh, is that? Oh.
Okay, so I'm taking a bypass here, right? As to why that's the case. Is that all right? Okay, so I know that this expression right in here is the same thing as log x y, correct? This expression right here It's the same thing as log xy, because they're added together, right? Are we okay with that? And that's times negative 1.
So any negative logarithm is under it.
Well, let's use the power property.
Because it's in negative.
The power property, this would become log
Please excuse the interruption. Could Julie Lynn please come to the front
xy
office?
to the negative 1, right? And log xy to, this is the argument of my logarithm right here. This is the argument of my logarithm. This is log 1 over xy, right? Which is the same thing as this right here, except that I forgot to write the word log in front. All right, does everybody see that?
Yeah.
Okay, back to our problem, so that Nicole doesn't have a heart attack. Okay, so we had our positive logarithmic expressions on the top, positive arguments on the top, negative arguments on the bottom, right? And it's an equation, so it equals 1. We okay with that? I have to solve this equation. I have all my variables are locked up in the logarithm prism. Okay? How do I free them from the logarithm prism?
You move the 2 and then to the other side so it becomes 2.
That's exactly right. I am exponentiating this equation. I'm taking them both to the second power. I'm taking them 2 to the power, right? So I'm going to take my 2. I'm going to move it over here to bump up that 1. So I now have that this is equal to 2 to the first. And all I'm left on the left-hand side here is 7x minus 8 divided by x plus 1. X minus 1 is equal to 2 to the first. Everybody okay with this? Yeah? Okay. So now, why don't I just kind of solve it? So I'm going to have 7x minus 8 over x squared plus 2x minus 1 is equal to 2. I just factored that out.
Wait.
X squared minus 1.
Yeah, because it's a plus and a negative.
Oh, you're right. It would be. I'm sorry. Thank you. Thank you. Thank you. My bad. My bad. X squared minus 1 is equal to 2, right? Okay. So now I'm gonna cross multiply.
Wait, how did you get x squared minus 1? Wouldn't it be like x squared? When you FOILed it. Yeah, x squared plus. No, because it then becomes plus x and minus x, which cancels out. X plus x squared plus x minus. Oh, wait, never mind.
Got it?
Yeah.
Okay. Dots. Dots. Right? Thank you. Okay. Okay. So now I have 7x minus 8 is equal to 2x squared minus 2. I just cross multiplied there. Okay. So now I have, I'm going to get everything on the, because I have a quadratic here. I want to solve a quadratic. I make it equal to 0. So I'm going to subtract 7x, and I'm going to add 8 to both sides. So I'm going to get 2x squared minus 7x. I'm adding 8 to both sides. That would be, plus 6 is equal to 0. So I need to know what factors of 12, 2 times 6 are going to give me 7. Are there any?
2 and 3.
No.
12.
Okay. I'm doing the surefire method of factoring this. Right? So I have my A times my C, which is 12. What factors of 12 give me negative 7? Yes, you're right. Negative 3 and negative 4. So I have 2x squared minus 3x minus 4x plus 6 is equal to 0. This is a good problem. I should put this one on the test. This is a good one.
Yes, you should. Yeah.
Okay. I'm going to go like this, and I'm going to go like this. But when I do that, because there's a negative sign there, I have to turn that into a negative sign. And now I'm going to factor, can I factor anything out of that? I think I could just factor x out of this side here, and I'm going to get 2x minus 3 minus, I can factor a 2 out of here, and I get 2x minus 3 over here equals 0. So I have x minus 2, 2x minus 3 equals 0. So I have x equals 2, and here I have x equals 3/2. No, wait. Are we okay here? What do I need to do? Oh, very good. Very good. I need to check 2 and 3/2. I'm going to go back to my original equation. Well, if I put a 2 here, I'm going to be okay, because that's going to give me a positive number. We okay with that? And if I put a 2 here, I'm going to be okay. That'll give me a positive number. And if I put a 2 here, I'll be okay. That'll give me a positive number. So I don't see any problems with the 2. How about 3/2? This would give me, if I multiply those times 3/2, it's going to give me 21/2, which is a little bit more than 10. So that's going to be a positive number. That'll be a positive number. And that'll be a positive number. So I don't think I have any problem. I think both of those answers will be correct.
Can you come down to the bottom so you can see the answers again? I just